Welcome to this video lesson. In this video, we are going to do some practice questions on average velocity and displacement and kind of using the position time graph and velocity time graph to come up with average velocity and displacement of objects. Okay, the first question. The following information are given. We get position 1 at 100 meters west, position 2 500 meters west, position 3 200 meters east, and position 4 is 150 meters west. The time it takes to travel between 1 to 2 is 4 seconds, 2 to 3, 3 seconds, and 3 to 4 is 2 seconds. And the first thing we want to do is we want to calculate the displacement from 1 to 2. To find the displacement from 1 to 2, we are going to take position 2. Note that whenever I use position, I don't put the triangle because it's not the change in position. Change in position would be displacement. We are trying to find, position minus position 1. The last one minus the first one. And I'm going to take my positive here to be, could do west. A lot of them are west in this case, but I'm going to take east as my positive. Doesn't really matter, we will get the same answer. So I'm going to use this sign convention all throughout my calculation, so I will put it here and I will actually highlight it as well. Okay, so now D2 is 500 meters west. West is opposite to east, so I have to use a negative value for it. So I'm going to use negative 500. And I'm going to subtract position 1, and position 1 is 100 west. So west is opposite of my positive sign convention, so I'm going to use negative value for that as well. And when I do this, I get negative 400 meters, and since my positive sign convention is east, that means my final displacement will also be in the east direction. For part B, I will need the displacement from 3 to 4. Another displacement, I will need position 4 subtracted by position 3. And position 4 is 150 meters west, opposite, so negative 150. And I'm going to subtract that by 200 meters east. East and east are same, so I'm going to use a positive value. The subtraction will give me negative 350. My unit is meters and my positive direction is east. Okay, I then need my total displacement. So for my total displacement, that will be the displacement from the very first position, which is 1 to 4. And that's going to be position 4 minus position 1. Position 4 is 150 meters west. That's opposite to east. I'm going to use a negative value. And position 1 is 100 meters west. So that's also negative. So I'm going to use negative 100. That's same as negative 150 plus 100, which is negative 50 meters, and my positive is east. Next, for part D, I'm asked to find the total distance. And for the total distance, I will need distance 1 to 2 traveled plus distance 2 to 3 traveled plus the distance 3 to 4 traveled. Now, I have the displacement 1 to 2, so the distance from 1 to 2 is 400. 2 to 3 I don't have, I need to do that calculation, and 3 to 4 is 350. So I just need this information here. So I'm going to do that separately, and let's do that just up here. We got displacement from 2 to 3, or I'll do the displacement and then I'll just calculate the distance right after. So this is going to be position 3 minus position 2. Position 3 is 200 meters east, so positive, and position 2 is 500 meters west, so negative 500, and that means that 700 meters was traveled in the east direction. So that's good. So now I have all my values that I can plug in. Remember that when you're doing distance, you don't need to care about direction. So from 1 to 2, again, is positive 400. From 2 to 3, I'm going to use 700. And for 3 to 4, 350. When I put all of that in my calculator, I should get 1450 meters, and I don't need a direction for this. Now, paying a little bit more attention to my work, I just realized that all of the positions are given to me in 1 decimal place. And if that's the case, that would mean the displacement should also have 1 decimal places, because I'm just adding and subtracting, or subtracting. So in this case, this one would be 400.0 meters east. Negative, and then this one would be negative 350.0 meters east. And I'm just going to box my answers here. Box. And this one is going to be negative 50.0 meters east. And this one is going to be 1450.0 meters. And now I am going to find the velocity so for part E, we're finding the velocity between 3 to 4. Whenever we find the velocity between 2 points, it's always the average velocity, because instantaneous velocity is only at one particular point, and we haven't yet learned how to find that yet. So this is going to be equal to the displacement from 3 to 4 divided by the time it takes to go from 3 to 4. I am still using east as my positive sign convention, so here the displacement from 3 to 4, as I have calculated before, is negative 350, and I'm going to divide that by the time from 3 to 4, which is 2, and that's going to give me 175, and my unit is going to be meters per second, because my distance or displacement is in meters and my time is in seconds. Now, I can see that when I made that division, my value here for the displacement was in 4 significant figures and my time was in 2 significant figures. When I multiply or divide, I have to use the least number of significant figures, so I have to round this number to 2 significant figures. And in this case, I will get 180 meters per second. I'm gonna box my answer here. And next, I'm asked to find the velocity or average velocity for the total. Usually, this is not a good way to label this. This would kind of mean the total velocity. That just doesn't make sense. What I mean by this, I'm actually going to change it from velocity from 1 to 4 as average velocity from 1 to 4. And that's going to have to do with the displacement from 1 to 4 divided by my time from 1 to 4. So what is that going to be? So we got our total displacement from 1 to 4 being negative 50. So I'm still using that convention. And the time from 1 to 4, well, I'm going to add some times here. So from 1 to 2 was 4 seconds, and then another 3 seconds, and then another 2 seconds. So that's 4 plus 3 plus 2. And 4 plus 3 is 7, and then plus 2 is 9. And when I do my calculation, I get approximately 20, well, I get exactly 25 meters per second, and my positive direction is east. I'm still using that convention. The only thing to notice here in terms of my significant figures, I had 3 significant figures here, and I had 2 significant figures when I added all of these up. I got 9.0. And when I divided my final answer, I had to add two significant figures, and it does have two significant figures, so that is my final answer. Finally, for the speed from 1 to 4, so you notice when it doesn't have the arrow, we're talking about the speed. And to find the average speed from 1 to 4, I gotta label my questions just to be a little bit more organized. Average speed from 1 to 4, I have to use my distance from 1 to 4. Notice I'm not using the arrows anymore, and the time from 1 to 4. So that's 1450, and that one has a lot of significant figures. Now I have 1, 2, 3, 4, 5, but I'm dividing it by the time, which is 4.0 plus 3.0 plus 2.0, 4 plus 3 plus 2. They all have one decimal place. My final answer is 9.0 there, and that would mean that my final answer, because of the limitation of the significant figures in the denominator, should also have two significant figures. So when I divide, I am going to get 161.1 repeated, and I have to change that to two significant figures, and that's going to be 160 meters per second. Notice that my final answer does not have a direction this time, and that's just because I'm talking about the speed, and speed doesn't take into account or average speed, sorry, I should use the proper terminology, and average speed doesn't take into account direction. So that was my first question. Let's try the second one. Assuming that all values are accurate to two significant figures, use the following graphs to calculate. So my keyword is calculate. I got to show some work. We want the average velocity from 0 to 2 seconds, average velocity from 3 to 5, and average velocity from 2 to 3 seconds. No problems here. So to find average velocity, first of all, I'm going to make this statement here. So, and then just use the idea. So to find average velocity, slope between 2 points. And let's do part A. So for time 0 to 2 seconds, I'm going to find my first point. This one is the one for 2 seconds. I'm going to connect them using a straight line. And the slope, or the change in displacement, you can also just use the displacement. Velocity between 0 to 2 seconds here is going to equal to, or the average velocity, the displacement. So that's the rise from here to here. And it's not rising, it's kind of falling. And the rise here, I'm going to write it as -2. And the run is how far it goes in this direction, and that's going to be 2. And this is going to be -1 meters per second. Do I need a direction? Yes, I do. This is average velocity, and for velocity, in this case, my positive sign convention is north, so I'm going to write that somewhere in the question, which is nice and clear. North is my positive sign convention, and that matches that. And here we go. So we have -1 meter per second north, or I can write that as 1 meters per second in the south direction. How about B? We're looking at 3 to 5 seconds. So 3 is here, 5 is here. The slope there, you got a rise. So I'll actually write it down first. The average velocity from 3 to 5 is going to equal to the rise in this case, which is -2 again. We can see that it starts here, goes down by 1, goes down by 2, so -2. And my run is from 3 to 4 and 4 to 5, that's 2 again. And that's also going to equal to -1 meters per second in the north direction. Finally, 2 to 3 seconds. So let's do that one here. So average velocity from 2 to 3 seconds here is going to be, so usually I use these for events or positions. In this case, just to make it easier, I'm just using it with time. And my rise here, let's do this one. I'm going to show it with maybe pink. It's a little bit easier to see. This is 2, this is 3. So I go up by 1, 2, 3, 4. So my rise is +4. And my run is 2.5 and 3. So just the 1. I don't know why I did 2 arrows, but from here to here is just 1 second. And once I do my calculation, let's get back to blue, that's going to equal to 4 meters per second in the north direction. Now, my answers, again, it says everything should be good to 2 significant figures, so I'm just going to change everything. This is -1.0 meters per second north. I'm going to highlight it. So see, sometimes I also forget significant figures and I go back and fix it, and obviously that's okay, but it's always nice to go back and check your answers and make sure that they are correctly written. So -1.0 meters per second north, and this one is going to equal to 4.0 meters per second north. Just one thing to note here too, we can see that in terms of like the slope, these ones are both like in terms of steepness, they're not that steep, and they're negative, and that makes sense. So negative, and they're not that steep. The value is only -1. You can see this one it is very steep, and it shows the value is much larger, and because the slope is positive, my value is also positive. Okay, I got another question, and well, this one is a long one. Let's do it. Assume the values are correct to 2 significant figures. Use the following graph to calculate the following. We want the displacement from 0 to 1, 1 to 2, 2 to 2.5, 2.5 to 3, 3 to 5, total displacement, and total distance. No problem. We can do this, and we know that basically based on everything that we've learned, to find the displacement from velocity time graph, so displacement will equal to area under the VT graph. So the displacement from the beginning, this point from 0 to 1, I need to find the area. So this area, we got an area of a triangle. So for A, the displacement, I'll use 0 to 1 is going to equal to, well, my height is -2, my base is 1. So 1 times -2 divided by 2, that's going to equal to -1. And I guess I do need meters is my unit. And I think I'm missing some information in this graph. So here the time is in seconds. I'm making it seconds because it's just a lot easier. And everything is good to 2 significant figures. So actually, I'm going to erase this and right away fix this and say 1.0 meters. And I got F here. F means forward, and B would be the opposite, which is backwards. So I'm going to take forward to be my positive sign convention, and this is going to be forward. For B, displacement from 1 to 2, that's the area in this region over here. Actually, why not draw it in different colors so we can kind of see the difference. So we're looking at that area, and in this case the height is -2 again, and my base is another 1. So this time I have a rectangle, so it's not an area of a triangle. I just multiply 1 by 1, 1 by -2, and I will get -2.0 meters forward. Okay, let's do the next section C. That's going to be D2 to 2.5, and that's this displacement. This is this area over here, and another rectangle. This time this is 0.5. This my height is -2 again, so I got 0.5 times -2. And I'm going to divide that by 2 because it's a triangle, base times height divided by 2, and I'm going to get -0.5 meters forward. Okay, the next section, I can use a different color, but one that is a little bit more visible, and maybe not the green there again. So we'll do this one in pink. This one, I believe this is D. This is displacement from 2.5 to 3. And another triangle, it's the same triangle as here, as you can see. It's pretty much the same, except it's in the opposite direction. So +2, 0.5. So I got 2 times 0.5 divided by 2, which is +0.5 meters forward. And finally, I'll go back to... Okay, let's actually do this as, maybe let's do it as blue. Do a dark blue. And here we go. So we got our last section over here. We got part E, that's the displacement from 3 to 5. And I'm forgetting some significant figures here, so 0 and 0. Everything is good to 2 significant figures. And okay, so for 3 to 5, I got a triangle, and for my triangle, the base is 2, my height is 2, so that's 2 times 2 divided by 2 because it's an area of a triangle, so 4, that's 2 meters forward. Okay, the next part of the question is asking me to find the total displacement and total distance. So for the total displacement, I'm just going to actually move this down to here. So part F, total displacement will equal to the displacement from 1 to 2, or 0 to 1 in this case. I'm just going to use the exact same things that I used here. So 0 to 1 seconds plus the displacement from 1 to 2 seconds plus the displacement from 2 to 2.5 plus the displacement from 2.5 to 3 plus the displacement 3 to 5, and I will put my arrows. And once I have this, and sorry, the total displacement is also from the very beginning, in this case times 0 all the way to the very end, which is 5. I have all my values in there, so I have -1.0 plus -2.0 plus -0.5 plus 0.5 plus 2. Luckily the math on this one isn't too challenging. I have -2 and 2 cancel out, these two cancel out, and I'm left with -1.0. Unit is meters. My positive sign convention here is forward, and that's my final displacement. So if the object went through all of these velocities, their final displacement would be -1 meters forward, or I can write it as 1 meter backward. Okay, let's shift everything to this side so we have a little bit more space to work on our very last part of the question, which is G, and that's the total distance. And the total distance is the distance from 0 to 1 traveled plus the distance from 1 to 2 plus the distance from 2 to 2.5 plus distance 2.5 to 3 plus the distance from 3 to 5. So for the distances, we don't care about the sign, or the direction, we only care about the positive or the magnitude of these values. So from 0 to 1, that was 1. 1 to 2, that was 2. 2 to 2.5, 0.5. And then 2.5 to 3, another 0.5, and then another 2. So we get 1 plus 2, 3, 3.5, 4, and 6 meters. Don't need any direction, but I do need to write things in proper number of significant figures, and everything has 1 decimal place, and when I'm adding, I gotta keep that. So the total distance is 6 meters.